Hi friends, welcome back. So in the previous session, we have seen aliasing process, sampling process. So what do you mean by sampling process? So we have seen it can convert a continuous time signal into discrete time signal, and we are having only ideal sampling. So in that ideal sampling, we have to multiply the original signal with the impulse train. And we have seen three cases in the sampling process. One is a oversampling, undersampling, Nyquist sampling. And we have seen to get back my original signal, at least the frequency must be the Nyquist frequency. That means omega s is equal to 2 omega m. So this is the condition what we can say is called as sampling theorem. What is sampling theorem is saying that? Sampling theorem. To reconstruct the original signal, to reconstruct the original signal the minimum sampling frequency must be 2 omega m. So this is what the sampling theorem is saying that. Take it. Okay. Let's take some important things you have to understand and remember. So what are the important things we have to remember about the omega m, that means maximum frequency. Once we know the maximum frequency, we can calculate sampling frequency. Suppose in the question they want to calculate sampling frequency, if nothing is given, then the default sampling frequency is always Nyquist frequency. So nothing is mentioned means then you have to say the sampling frequency is equal to 2 omega m. So to say 2 omega m, we have to know what is the omega m value, that is maximum frequency. Remember, to find out the maximum frequency, always observe the wave in the frequency domain. That means we have to observe only the spectrum. From the spectrum only we can identify what is the maximum frequency. So don't see the signal in the time domain, because in the time domain we cannot find what is the maximum frequency. But in the frequency domain only we can say what is the maximum frequency. I am telling you again, to find the maximum frequency, always concentrate on the spectrum, not on the waveform, that is in the time domain. So I hope you understood. Always concentrate on the frequency domain wave, that is nothing but spectrum. Okay. So here let's see. Suppose we are having two signals, x1 of t having x1 of omega, which is let's say like this, omega 1 0 minus omega 1. Next, another signal, let's say x2 of t having spectrum x2 of omega, which can be like this. That means the first signal having maximum frequency omega 1, the second signal having maximum frequency omega 2. Okay. Now, if I consider a signal, first case, x of t, which is combination of x1 of t and x2 of t. If I add these two signals, then what is the maximum frequency of this signal x of t? I hope you understood what I am trying to ask. Two signals individually we came to know, that is maximum frequency of x1 of t is equal to omega 1, maximum frequency of x2 of t is equal to omega 2. If I ask what is the maximum frequency of this signal x of t, which is x1 of t plus x2 of t, then you have to understand. I told you, whenever you want to calculate the maximum frequency, always concentrate on the frequency domain. If I add two signals in the time domain, in the frequency domain also we have to add these two signals. So if I add these two signals, what is the maximum frequency? Depending on omega 1, omega 2. So if I add, suppose if this is the case I have taken where omega 2 is more than omega 1, then if I add these two signals, then I am going to get the overall signal is up to omega 2. So in general, if I ask, so out of omega 1 and omega 2, whichever is the maximum value, that is what the maximum value for overall signal x of t. So I hope you understood. So I can write here the maximum frequency omega m is nothing but maximum of omega 1, omega 2, like that. So whichever is the maximum value out of these two, that is what we have to consider. Next, second case. If I take a signal x of t, which is multiplication of x1 of t and x2 of t, or we can say convolution better. First I will go for convolution. So two signals are getting convolved, then what is the maximum frequency? And again I am telling you, to calculate the maximum frequency, always concentrate on the frequency domain. So if I concentrate on the frequency domain, so if two signals are getting convolved in the time domain, then what will happen to in the frequency domain? So in the frequency domain, they get multiplied. So if I multiply these two signals, so up to what is the maximum frequency we can get? So if I say in this case up to omega 1 we are going to get. Why? Because omega 1 is the lower value. So up to this value we are going to get, after this is 0 multiplied with this signal is going to be 0. So I can say in this particular case we are going to get omega 1 is the maximum value. So can I simply say out of omega 1, omega 2 in general, whichever is the minimum value, that is what we have to calculate. So in general we can say omega m is equal to minimum of omega 1, omega 2. Minimum of omega 1, omega 2. This is what we are going to get. Next, third case. X of t is equal to x1 of t multiplied with x2 of t. For this signal, what is the maximum frequency? For this signal, what is the maximum frequency? If you observe carefully, again we have to observe the frequency domain. If two signals are getting multiplied in the time domain, what will happen to in the frequency domain? They get convolved. So if I do the convolution, then what will happen? I am going to get the maximum limit is nothing but sum of maximum limits. So we have seen in the convolution properties. So if you want to calculate the upper limit, this is the sum of upper limits. So to get the maximum value, what I have to do? I have to add these two maximum values. So for this case, we are going to get omega m is nothing but omega 1 plus omega 2. I hope you understood why. So I am just writing here. From this we can say x of omega is equal to x1 of omega plus x2 of omega. From this we can say x of omega is equal to x1 of omega multiplied with x2 of omega. For this we can say x of omega is equal to 1 by 2 pi x1 of omega convolution with x2 of omega. So because of this we can say these are the maximum frequencies. Now in general, if I ask x of t is equal to x1 of t multiplied with x1 of t. So I have multiplied this signal again and again. So what we are going to get? I can get x1 square. So if I ask x of t is equal to x1 square of t. For this signal, what is the maximum frequency? So many people think that it is omega 1. No, it is not omega 1 actually. So it is similar to that of x1 of t multiplied with x2 of t. Sorry, x1 of t again. So it is again multiplication. If it is multiplied in the time domain, they get convolved. Then what we are going to get? Omega 1 plus omega 1. That is nothing but 2 omega 1. So we are going to get the maximum frequency 2 omega 1. In the similar manner, if x of t is equal to x1 of t whole cube, for this signal we are going to get maximum frequency is equal to 3 omega m. So in general x of t is equal to x power n x1 of t whole power n. For this one, the maximum frequency is n into omega 1. N into omega. Clear? Take it. Let's take some questions. Find sampling frequency for following signals. Find sampling frequency. So remember, sampling frequency means if nothing is mentioned, this is nothing but 2 omega m radians per second. Or we can write Fs, that is nothing but 2 Fm, or sometimes omega s by 2 pi. So if I know omega s, we can directly calculate Fs. Simply divide with 2 pi. So it is samples per second or hertz. The unit is hertz or samples per second. Let's take some examples. Example: x of t is equal to sine at by pi t. For this signal, I want to calculate omega s. First of all, we have to know what is omega m. I told you, whenever you want to say omega m, just you have to go for the spectrum only. That means in the frequency domain. So for this, what is x of omega? So it is nothing but a rectangular pulse. We have seen it is an ideal low pass filter. 0 minus a plus a 1 omega. So from this signal, what is the maximum frequency omega m? That is a radians per second. So once we got the omega m, what is omega s? That is nothing but 2 omega m. That is nothing but 2a radians per second. If I want Fs, that is nothing but 2 omega s by 2 pi. That is a by pi samples per second. Samples per second. So you just have to remember one thing here, that is omega m, the maximum frequency is nothing but a radians per second. So that is nothing but the cutoff frequency for ideal low pass filter. Clear? Take it. This is even same for sampling signal also. Suppose if it is given x of t is equal to sampling at, that is sin at by at. So for this also omega m is equal to a radians per second only. But what if x of t is given sinc at, then this can be written as sin pi at by pi at. But here what is the omega m value? That is pi a. So these are the things you have to remember. For a sinc function, pi a. For a sampling function, it is a. Take it. X of t is equal to sinc 300t plus sinc 200t. So here we are having two signals, which is addition. Now we came to know for this signal what is omega 1 value, that is nothing but 300 pi. For this signal omega 2, that is the maximum frequency, is nothing but 200 pi. And they are getting sum. Then what is the maximum frequency? Omega m, that is omega 1 and omega 2, whichever is the maximum value for that. Maximum of 300 pi comma 200 pi, which is 300 pi. Then what is omega s? 2 omega m, that is 600 pi. Then what is fs? 300 hertz or samples per second. Take it. Do the question by yourself so that you can get it. Next, x of t is equal to sinc 300t convolution with sinc 200t. So again they are getting convolved. So here omega 1 is equal to 300 pi, omega 2 is equal to 200 pi. Then what is omega m? That is nothing but minimum of 300 pi comma 200 pi, which is going to be 200 pi. Then what is omega s? 2 omega m, that is nothing but 400 pi. Fs, that is 200 samples per second. Next example, x of t is equal to sinc 300t into sinc 200t. Sinc 200t. So again omega 1, omega 2 values are same. So whenever they get multiplied, then what is the omega m value? That is nothing but addition of maximum frequencies. 300 pi multiplied with 200 pi. Sorry, addition with 200 pi. Then that is going to be 500 pi. What is omega s here? 2 omega m, that is 1000 pi. Then what is fs? Fs is equal to 500 samples per second. Take it. x of t is equal to 5 sine 300t by pi t whole power cube plus 7 sine 300t by pi t whole square. For this one, we have to calculate what is omega s value. So first of all, for this one, 300 is the frequency omega m, and we are having cube. Then for this signal, what is omega 1? 3 into 300. Then that is going to be 900. For this signal, omega 2 is equal to 2 into 300. That is 600. Because they are sum, then what is omega m? That is maximum of 900 comma 600. That is 900 only. Then what is omega s? 2 omega m, 2 into 900. That is 1800. Then what is fs? Omega s by 2 pi. That is equal to 900 by pi hertz or samples per second. Take it. Next example. X of t is equal to sine 300t plus cos 500t. So it is not a sinc function or sampling function, something like that. It is simply sine and cosine wave. So whenever sine wave and cosine wave are given, you know that sine wave is having only one frequency, cosine wave is also having only one frequency. Here it is having only one frequency, 300 radians per second. It is having 500 radians per second. So only one frequency we are having, that frequency itself we will take as a maximum frequency. So here for this signal, remember omega 1 is equal to 300. For this signal, omega 2 is equal to 500. Now what is omega m? Maximum of 300 comma 500. So which is 500. Then what is omega s? 2 into 500, 1000. Then what is fs? Omega s by 2 pi, 500 by pi hertz. So this is what the, suppose if sine or cos is given, directly you can take that frequency itself is nothing but the maximum frequency, because sine and cos having only single frequency. Take it. Next example, suppose if x of t is shown like this. What is the omega s? That is sampling frequency. Here so many people will take omega s is equal to 2 into 5, that is 10. which is absolutely wrong. Absolutely wrong. I told you to calculate omega m, always concentrate on spectrum, not on x of t. That means x of omega we have to see. So by saying that, it is not going to be correct. That means to find omega m, always consider x of omega, not x of t. So what is x of omega for this signal? X of omega is nothing but, we know for a rectangular pulse we are going to get sampling, so it is nothing but 10 sampling 5 omega, sampling 5 omega. So if I draw this x of omega, then it is going to look like this. So at this point, now if I say what is the maximum frequency for the signal, so omega m is equal to infinity. So we don't have any omega s. Suppose if I take omega s, which is nothing but infinity, that means if you take any finite value for omega s, so if I shift this signal at any amount, still it is going to interfere with the original signal. I hope you understood. So if it is x of omega, then if I shift it to any amount, still it is going to interfere. That means always aliasing effect occurs or not. So in this case, interference always occurs. You can never get back the original signal. That means first of all, sampling theorem is not applicable for this signal. Why? Because it is a band unlimited signal. Here the bandwidth of the signal is infinity. So it is band unlimited signal. Band unlimited signal. So sampling theorem not applicable. Is not applicable. Take it. Not applicable. Take down this question. A signal, take down simultaneously, x of t is equal to cos 10 pi t is ideally sampled at 15 Hz at a rate of 15 Hz and passed through a low pass filter, with cutoff frequency Fc is equal to 12 Hz. What are the frequency components? What are the frequency components? Will appear at the output of filter. Okay, listen. So we are having one signal x of t, and it is sampled at a frequency how much? 15 Hz. At a frequency 15 Hz. And it is passed through a low pass filter with a cutoff frequency. So then what are the frequency components will appear? So first let's see. what is x of t, which is cos 10 pi t. So everything in the head, then we have to calculate fm, that is also 10 pi by 2 pi, that is nothing but 5h. So for a cosine wave, what is x of omega, or x of f, sorry, x of f with respect to f? I already draw for cos t or cos omega naught t what is the spectrum. So it is having two impulses. One is at f naught, so how much it is, 5h. Another one is at minus 5. So this is what the original signal, x of f. Now if it is a sampled with a frequency, this is nothing but 15 Hz. So x s of f, where fs is equal to 15 Hz. That means it is shifted 15 Hz minus 15 Hz like that. So what is xs of f? With respect to f, let's see. So the original signal, which is minus 5 plus 5, this is the original one. Next, what will happen? It is shifted left side and right side with 15 Hz. So where it will go? It will go to 15 Hz. So then what will happen? This will go to 10 Hz. 10, 15, 20. Again it is shifted to 15 Hz. Then what will happen? Where it will go? So if I add 15 here, so that is going to be 25. So this is 30, this is 35, like that it will go. So and so on, it will go in this direction also. Now I am not taking this one because I will concentrate only on positive frequencies. Now this signal is passed through a low pass filter with 12 Hz cutoff frequency. If it is passed through a low pass filter with 12 Hz cutoff frequency, then what will happen? This is what the 12 Hz. So this is low pass filter. Then what are the frequencies at the output, which are nothing but 5 and 10 Hz. So 5 Hz and 10 Hz. So this problem can be solved without much difficulty or without drawing these kind of things directly also. Let's say how we can say. First of all, we have to know what is x of f. So for x of f, what are the frequencies we are having? So one is minus 5 and plus 5. Now it has to be shifted. So if it is shifted, then x of f minus 15. Then if it is minus 15, so we have to add. So it is 10 and 20. 10 and 20. Then x of f minus 2 into 15. Then again we have to add. There is nothing but 25 and this is 35. So and so on it will go. Now it is passed through a low pass filter with 12 Hz. That means we have to consider only up to 12 Hz. So if I consider up to 12 Hz, that is going to be 5 and 10. So these are the frequencies which will pass through low pass filter, and other frequency cannot come out of this filter. Clear? Take it. You can try as a homework. If Fs is equal to 8 Hz. If Fs is equal to 8 Hz, then the output frequencies you are going to get 3 Hz and 5 Hz and 11 Hz. 11 Hz. These are the output you are going to get if you try for. So you can go in this method only. So suppose let's say the original frequencies are -5 and 5. If it is 8 Hz, then it is going to be 3 and so it is going to be 13. Again, if it is 8 Hz, so this is going to be 11 and 21. Again, if it is 8, so it is 19 and let's say 32, like that. So in this one, which are the frequencies below 12 Hz? So 5, 13, excuse me, 11. So these are the frequencies below 12 Hz. So if it is passed through a low pass filter with Fs is equal to 8 Hz, then 3 Hz, 5 Hz and 11 Hz, which are coming out of the filter. Clear? Take it. Okay. Let's see one example. If a signal x of t has Nyquist rate omega naught, then find Nyquist rate of x of 3t and x of t by 3. What is the Nyquist rate of x of 3t? What is the Nyquist rate of x of t by 3? Listen. Let x of t having x of omega, which is like this. And they said for this omega naught is equal to 2 omega m Nyquist rate. Now let's say I want to see what is x of 3t. For x of 3t, what is the Fourier transform? 1 by 3 x of omega by 3. What is x of omega by 3? That is actually expanded version. So if it is expanded, then it is having the maximum frequency, which is nothing but 3 omega m. 3 omega m. So if it is 3 omega m, then what is the Nyquist rate? Omega naught dash. That is nothing but 2 into 3 omega m. So that is nothing but 3 omega naught. 3 omega naught. In the similar manner, suppose if I go for x of t by 3. X of t by 3 means 3x of 3 omega. That means it is a compression. If it is a compression, then we are going to get the frequency is omega m by 3. Omega m by 3. Then what is new Nyquist rate? 2 into omega m by 3. That is nothing but omega naught by 3. Clear? Take it. Last and final thing in the sampling theorem, band pass sampling. So the signal what we have is nothing but band pass signal. Band pass signal. Just the formula you have to remember. So here the omega s is nothing but, or we can say fs. Fs. Sampling frequency is not 2f2 here, it is nothing but 2f2 by k, where k is the integer part of f2 minus f1 by f2 by f2 minus f1. So that's what the thing we have to remember. Take it. To make you understood, suppose if I take a 5.6 megahertz and 6.8 megahertz, then what is the k value for this? 6.8 by 6.8 minus 5.6. For this one we have to calculate integer. So what is that? This is actually integer part of 5.6, which is nothing but 5 only. Then what is fs? 2 into 6.8 by 5. 2 into 6.8 by 5. That is nothing but 2.72 megahertz. So try to understand. Band pass sampling is not like a baseband sampling. Here one extra term what we are going to get is k. So if it is a baseband sampling, directly we can go for 2f2, but here it is not. It is the case we get. Clear? Take it. With this we can complete the sampling theorem. In the next session onwards we will start the Laplace transform. Okay.